Hello, welcome. This is now question 2 for Edexcel's FP1 June 2015 paper. Okay, so we're given, now it's not labelled as an equation of x, although I think it should be. Maybe it's just the wording's messed with my head, or the fact that I'm a bit thick, but anyway. We're told that this is this equation, 3 plus x times sine x over 4 equals 0, and this occurs where there is it has an interval in the range 13 between 13 and 14. Okay, and we're also told that x over 4 is measured in x is measured in radians. And now obviously that doesn't apply for this x times sine of this, but the x in the sine, so the sine of x over 4, that's measured in radians, is what it's trying to say. And it has exactly one root. Now the two questions here, they're just different ways of finding that root. Okay. Now, in the first question, we looked at an equation, a cubic equation, where we had to find its root, essentially, its roots. Now, that was just algebraic line division, but in this, it explicitly tells us what method to use. Okay, so it says starting with the interval 13 and 14. Well, obviously we're not going to start with a different one. Use, now this is the key word, use interval bisection twice to find an interval of width 0.25. And that's quite obvious really, because interval bisection, in essence, it's cancelling down half in it and then looking at one half of the range and see if there's a change of sign, and looking at the other half of the range and seeing if there's a change of sign. And in the one that there isn't, you cross off. Okay, you ignore that half of the range because it's not going to change sign, and then you check that. And you continue that method until how many times it tells you. Now, it's the bit where it says twice, that might confuse you. You might think, well, yes, but what does that actually look like as a method? But it's backed it up by saying width 0.25. So obviously, looking at which quarter, okay, is there a change of sign? Okay, so we know there's a change of sign in between 13 and 14. Okay, but it's still worth showing that. Okay, just to prove it to yourself. And I'm not 100% certain you don't. You need to do this, but I did it anyway. So to prove that there's a change of sign. Now the reason we do the f of 13, reason why we sub in 13 and 14 and see what it comes out to be, is because if there's a change of sign, we need to know, well, what was it originally for the sign to have changed. Okay, and you always take it from the perspective that the original sign was the lowest x coordinate. In other words, the sign that this did have, just take it as a given that it's a lower one, and that was 13. Now obviously you can do it from the perspective that it was 14, and go the other way, but it's just confusing. Okay, so anyway, just sub 13 into the equation. Okay, so it's obviously 3 plus 13 times the sine of 13 over 4. Okay, and you should get a positive figure. Now, we're not bothered what that figure is, as long as it's positive, we don't really care. 1.59, etc, etc. And you don't need to really state, you just need to make sure it's positive, really. Okay, so therefore, quite clearly, f of 14 should turn out to be negative. So 3 plus 14 times the sine 14 over 4 is equal to minus 1.91. So that makes sense. Okay, so what I always do in these situations is kind of draw like a little table. Now what I mean by a little table is kind of, it's almost like a babyish number line kind of thing. And you might want to draw a few of them, or just one, it's up to you. Okay, so obviously we're looking at of the range between 13 and 14. So the extremities of this number line, very, very advanced maths, 13 and 14. Okay, so 14. Now, what we're going to check now, we proved that there's a change of sign between 13 and 14, but it wants it where there's a width of 0.25. Now, I could break it up into quarters there, but we're not looking at the quarter straight away. We need to know, well, interval bisection is where you split it up into halves. So obviously you need to do it again and again to get it in quarters. So the first thing that we need to check, obviously by following the method that we've cut it in half essentially, is, well, what is the value at 13.5? Okay, so Therefore, if 13.5 is positive, then there's no change of sign between 13 and 13.5, because 13 is positive, and we assume it's not going to weirdly, do some drastic decrease and increase between 13 and 13.5 that we don't see, because, well, this curve, just by looking at the equation, it is a sine curve, and it's just some manipulation of a sine curve where it's been stretched and shifted. Okay, but there's no point trying to draw it. We just simply do this. Okay, so anyway, if it is positive, okay, well, the change of sign doesn't occur between 13 and 13.5. Therefore, it must occur between 13.5 and 14. So we halve that section again. But if there's a change of sign between 13 and 13.5, then we cross out the range on the right, because we know there's not going to be a change of sign between 13 and 13.5. This is all hypothetical, by the way. We're just going to find out what 13.5 is. So we sub in 13.5. So you do the f of 13.5. Okay, so it's 3 plus 13.5 times the sine of 13.5 over 4. Okay, and you have to remember, sorry, I think I mentioned it before anyway, but you need to make sure that you calculate this in radians. Obviously, otherwise you'll get some degree answer, which will clearly is not right. Okay, so anyway, you would sub in that and you will get an answer of minus 0.122, etc, etc. Now the key thing there is obviously there's a minus. So at 13 it was positive, and at 13.5 it's now turned to negative. Okay, so we cross out the range which is greater than 13.5, because we know there's not going to be a change of sign there. Okay, you cross all that range out. So this is why I'm not going to draw it again in a bit. Now the reason that we're doing this, okay, just to put it into perspective, I think hopefully you know it, but I'll just give you a brief example. So this is, we've got an x and y axis here. What we're doing here is when we sub in 13, what we're doing is saying x is 13 and we're subbing in y, because what this really says is y is equal to that. But it's not put y, it's not even put f of x. It should have done really, it's been quite nasty in that respect. Anyway, so it's just an equation. So in other words, it'd do something like this. Okay, and say we're looking at it, it's 13 positive. Yeah, we might be looking at it in that range, okay? So 13 and 14. I know it's on a negative, but anyway, just bear with me. Might be looking at it there, okay? So obviously we know it's 13.5. That is a positive y value, so it might be somewhere up there. But when it goes negative, we're saying, well, when we sub a value for x in, we get a negative y value, so it might be like that. Okay? So basically, this is just showing us when we sub in an x coordinate, is it above or below the x-axis? And obviously, if it's if it was below and it's got above, it's going to go negative to positive. That's very, very basic, and you probably already knew that. But yeah, it's just an example of why we can use this method. Really, it's just kind of a method of guessing more than anything. Okay, so anyway, apart from just a brief overview of what we mean by interval bisection, but if you're not sure, just check out the video I do. Anyway, so we've crossed out the range because we know there's not going to be a change of sign between 13.5 and 14. Well, we've already proved that really by saying, well, what's the sign at 14 and what's the sign at 13.5? So that was doing it once, okay? So you might want to put a little star saying, therefore, at that point, we've done interval bisection once. That's interval bisection doing it once. That's when you cross out one little bit of the range, okay? When you do it twice, you cross out another little bit of the range. In other words, you do that little crossing out business, but you do it twice if you do it twice. Makes sense. Okay, so anyway, we know there's a change of sign between 13 and 13.5, but it wants a width of the range to be 0.25. Quite clearly, we've got it at 0.5, so you need to half it again, and then we don't need to do it anymore. Okay, so obviously, half the range, you can do it in a calculator, but it's quite obviously just 13.25. So we need to say, is there a change of sign between 13 and 13.25, or is the change of sign between 13.25 and 13.5? Well, we know it's positive at 13, okay, and we know it's negative at 13.5. So if 13.25 is positive, then, well, if 13 is positive as well, then a change of sign is going to be between 13.25 and 13.5. But if 13.25 is negative, okay, well then there's been a change of sign between 13 and 13.25. So we need to see what that comes out to be. Okay, so we sub 13.25 into the equation. In other words, we do the f of 13.25. Now, as I said, I wrote f of 13, f of 14, etc, etc. I could have just wrote sub 13.25 into the equation as x, but as I said, it's just simpler. So it's 3 plus 13.25 times the sine of 13.25 over 4, and in essence you should get positive 0.7. Okay, now we know that 13.25 is positive. Okay, so as 13 is positive as well, we assume there's not been a change of sign between 13 and 13.25. And as we've done two crossing out little bits of the range, we can say therefore that's the second time we've done interval bisection. And it tells us, now we need to stop there, because it's told us they want a width of the range where the sign changes to be 0.25, which it is, and we need to do it twice, which we have. Okay, so therefore we know it changes sign between 13.25 and 13.5, but we need to put it in a kind of format they've done, which is very, very basic, just saying it's between these two. So therefore it's between 13.25 is greater than 13.25 and less than 13.5. But you might go, well, why are we not putting up to and equal then? Sorry, less than and equal to, or greater than and equal to. Well, because the change of sign is not going to happen every single point between 13.25 and 13.5. It's going to happen at one point between them two. So it's key to write it as just simply standard inequality. Okay, so that would be your answer. Okay, so just write it back over here, because obviously I'm going to be rubbing all this out. So 13.25 and 13.5. Now you could write 13.50 just to make it look a bit nicer, because they're both to the same number of decimal points, but it doesn't really matter. Okay, so what the next part of the question says. Okay, so the next part of the question, 2b, says use linear interpolation once, so this is a bit easier almost, on the interval between 13 and 14 to find an approximate value for the root, okay, labelled as the root as little a, or alpha, if you want to call it, and give your answers to 3 decimal places. Now, remember, linear interpolation is all about this similar triangles business, okay? And as I said, if you don't get why that is, then please do check out my video on linear interpolation. But what I'm going to do is just tidy this up and just draw a couple of points, because I don't want to spend 5 minutes trying to draw it while you're trying to watch me draw it, okay? So I'll just skip to myself drawing it. 1 sec. Okay, so what I've drawn here is, well, we only need to draw it once, okay? Because we're only using linear interpolation once. Now that would change slightly differently when we do it more than once, but obviously if you're not sure about that, please do check out my video on linear interpolation, which obviously should be up. So I keep referring to these videos, and some of them might not even be up yet, so please do check a video out that actually isn't on mine yet. It probably just hack into my computer or something. Hopefully not, and you just wait. Anyway, okay, so what I've drawn here is kind of giving you a bit of a head start, because I couldn't be bothered writing it while I was trying to explain it to you. Okay, so what we've got here is a very, very crude diagram of the curve. Now, quite clearly, from the looks of that, it's not going to be a linear graph, but we assume it is, because we would like to make things look easy. Okay, and the principle stands. Now, what we've got here is this black line meant to represent the curve, and it intersects the x-axis, because that solution, what is the solution, that's what we're trying to find out, and I'll label it little a. Now these coloured lines, okay, and the dotted ones, they're just meant to show you when you correspond one point, okay, so the end of this graph is where x is 14, because that's the maximum end of the range, okay, and the minimum end is 13, okay, so that's where this black line starts from. And what this is just showing you is just when x is 14, we get a y value of minus 1.91. Now, we did work that out just in the part A, but I didn't label it, didn't put the coordinates down precisely, but essentially you could work out, well, what is y when x is 14, but you've already done that, as I said. Okay, so then I just drew these these dotted lines here. So what this shows, I'm kind of focusing on the green ones now. Obviously, the height of each of these triangles is, well, what is their y coordinate? Okay, and obviously the height of the A is 1.59, whatever. Okay, you just save it, leave it as a saved answer in your calculator. Okay, so, and the base of that triangle, or the length, as I've referred to over here, is 13 take A, because quite clearly A is a bigger x value than 13. Okay, vice versa, for triangle B, I've put the length, okay, or the change in x coordinates even, is 14 minus A, because obviously 14 is bigger than A. Okay, because we know A is somewhere between 13 and 14. Okay, so therefore the height of triangle B is what? It's not minus 1.91. That's a key thing to get wrong there. Sorry, a key thing to avoid. Not purposely on purpose to get wrong, but you could do it if you wanted to. If you wanted me to get a bit of grades. Anyway, so the height of each triangle is their respective y coordinates. Obviously, turn positive if needed to. Okay, so apply all of this information into this similar triangle. This is just a ratio. It just says the height of each triangle will be a ratio. One will be a ratio of the other. So that will be equal to the ratio of the lengths. Okay, so that's just really what this equation is saying. But hopefully you know about some of the triangles already. Okay, so anyway, the height of triangle A, well, that's 1.59. Now, as I said, because we got that height from inputting 13 into the calculator, you could just simply write that equation again, but have 13 to be x, okay, instead of writing 1.59. Just, it'll increase your accuracy, but so it's not really that bothered. The height of triangle B, well again, similar kind of thing, that's 1.91, etc, etc. And that is equal to the length of triangle A over the length of triangle B. Well, the length of triangle A is 13 minus A, and the length of triangle B is 14 minus A. And you might go, well, normally it doesn't matter what triangle you pick as A and what triangle you pick as B. Okay, obviously it does when I've wrote what the values are for A and B. Okay, but as I said, it doesn't matter. It's just coming up with that kind of equation thing. So what we're going to do is obviously you would work out exactly what that division is, 1.59, etc, etc, over 1.91, which I think comes to 0.83ish. Okay, so as I said, I'll put that in just around about. So it's around about 0.83, etc, etc, and that is equal to 13 minus A over 14 minus A. This A being the alpha, the intersect. This is the first approximation, in other words. Times both sides by 14 take A. Okay, and then you would divide. Sorry, yeah, times both sides by 13. Sorry, yeah, both sides by 14 take A. So you would have 0.83, etc, etc, times 14 take A, and that is equal to 13 take A. Then you would expand the brackets. In other words, you do 0.83, etc, etc, times 14, and then obviously 0.83, etc, etc, times minus A, because obviously you're taking away A. Okay, so then it's just a case of simplifying it down. Okay, and then I'm putting all the A's on one side and all the numbers on the other, which I'm assuming you can do quite easily by just expanding that. As I said, the rounding error is going to be your biggest enemy here, but as I said, I would just round it up and keep it. If you're going to round one of them, round them all. Don't try and just round one of them, because it won't work out so well. Okay, but I gave it a specific answers. Now I'm not going to go through how I rearrange that to get A, but hopefully you further maths people, you can see how that is done. Just simply expand that. So 0.83 times 14, 0.83 times A minus A, and then obviously you would get an equation there. I'm not going to say it out because I put too many decimal places. I put it to the exact figure, okay? And then rearrange to get A, and you get A because it wants it to 3 decimal places. This is why I don't like rounding it, because if it says to 3 decimal places and you've rounded it, well, if you've rounded it to less than 3 decimal places, well, then obviously that's going to be wrong, because you're going to be now putting it to a greater degree of accuracy than you originally had it. Anyway, okay, so when you do that and rearrange it, you'll get A to be 13.455 to 3 decimal places. Okay, and if you just simply put 13.455 into your equation for y, you get an equation, a value which is very, very, very near 0. Okay, but obviously you keep need to redoing this method to get an exact approximation for the value. But that's good enough for this answer, because it's only asked you to do it once. Okay, so hopefully that seems fairly quite self-explanatory. Okay, so thanks for watching. Hopefully we'll see you in the next video.